Cartus is in the house. Pump it up. Get loud, loud. Dance until the lights go out. Feel the beat. No doubt. No doubt. Let's go, let's show the love we grow. Turn it up, party on till we blow. Get down, get wild, lose all control. Cartus brings the heat, let's steal the show. Gate today, welcome to the show. Crack open a tin and let the banner flow. Thinking fun with the twitchy crew. MJ's in the house and it's all for you.
While as congas a cheeky room, who sits stage spot on the screen for you. The meat for thongs or court hat flare. Just grab your tin tans and pull up a chair.
Good day, welcome to the show. Crack open a tin and let the banner flow.
Raise your glass and shout to right.
Jay's in the chat, wanna rip a night.
Jump in the ride, let's hit the road. Jeep is here with the tail to unload. Cats in the back, vibing on the beat. Rockets looking now they're obsolete. Welcome to the chaos, feel the vibe. Oh, chicken street, we're alive. Let's jive.
It's hot. It's hot. I'm hot. I wish this weather would finish. Hello. Another sweaty day here. Oh, hello Carrot House, hello MJ, hello G-Pin, hello Swarm. Bloody Swarm, if you ask me. Not you, the weather. Right, we are going back on to this development board again. And a Daft Punkle. Development board. We want to get some output from it today.
CRT screen, start to giggle. Keyboard keys, do a little wiggle. So the smoke smells like bubble gum.
Let's brighten that up a bit, shall we? Where's my little wheel gone? There it is. I might even focus it as well, if you're lucky. Maybe. You're waiting for the oven to heat up due to having minimum food ideas. Just hold it outside the front door for 5 minutes, it'll get pretty hot then. Right, yes, we want to get some output on this today, if we can, of some form. And to that end, I have my box. Now with added bubble wrap. A box full of screens. See if there's anything suitable in here. I don't think we want one that big. Right, what have we got in the way of LCDs? There's one that's got a pick on the back of it. That's a possibility. I want an ordinary text-based LCD. That's a possibility. Maybe. I'm not sure what that one is. Might be graphical. There's a... That looks like a transflexive one to me. It's also got a 3.3 volt label on it, which isn't good. Or we could do a little I2C OLED. Oh, I've got a big one there. It needs to be a text-based one. That's a possibility. I'm not sure what the protocol is for that one. Hey, Mars! How you doing? Oh, we've got an e-paper one there. It'd be fun to have an e-paper one on it. That's
Champion!
that I think is SPI.
With 50 bits, Chloe Raccoon says.
Cheer 50 egg. Oh, you said screens.
Screens, not screams. Oh, that nice big chunky one. I think these are all graphical. Yeah, that'll be graphical, I think. Graphical's no good because if I want to put output text, I have to have a font embedded in the code to output the text as. And with only a couple of kilobytes of space, that ain't gonna happen. Big chunky one? Hey, I've lost weight. Yeah, okay. But I think this one here is a text one.
With 100 bits, RHK77 says.
Hello Cheer 100 happy tinkering.
Thank you very much for 100 bits, RHK. You just started learning microcontrollers, started with Arduino, then you'll do ESP32, then PicoW. Excellent, excellent. I mean, you can program them all as Arduino, and there's very little difference in how you actually use them. If you just stick to the Arduino framework. If you want to get more technical, you can do direct programming of them. But sticking to the Arduino framework, everything's pretty samey, really. It's just what facilities each one has. Right, these are our candidates at the moment. And I can't remember what they all are. So I'm going to have to do some looking up of data sheets. Zoop. Let's start with this one. I think this one's an OLED. And this is a TW2832230B. And the Paul McWhirter YouTube videos for Arduino. A bit hot in Texas, a bit hot here too. You've got workshop in the garage, that is going to be hot. Right, so let's have a look for the TW2832230B. It gives me watches, great. It's by Topwin, hence the TW. OLED, 2.23 inch, 128 by 32 resolution. It's graphical. That rules that one out unless it has a text mode. And it's the SSD 1305 or 1309. That doesn't have a text mode as far as I know. Doesn't have an embedded font. No. Just graphics. So that rules that one out. That's a shame. That's quite a nice little display. Al Janet, hello.
Drummers in the house tonight, bringing love and lighting up the night.
Yes, I'm jealous of your little e-ink reader.
Everything's alright.
So that's a no-no because it's graphical. We can't use that one, or not easily.
In the house, will he
This one here,
feel the synth pop?
I think this is a 40 by 4
Drummers in the house,
text display.
night. Dance together through this endless night.
And we've got 05 data clock on a sticker there. I don't know what this is set up for, but C2004A. Let's see if I can find that. You need to finish unpacking and retrieve your USB hub with Ethernet from the crate full of tent kit. It's unwatchable as it appears to be saturating your Wi-Fi with a backup. Well, that's silly, isn't it? About 3 hours is the estimate. Oh dear, oh dear. Yeah, get unpacking. Right, so we are looking for the C2004A LCD. It's a 20 by 4 character LCD module by the looks of things. Oh, goddamn scribd. Scribd should not exist. Go away. LCM 2004A, I believe that's the same thing. It looks very similar. It looks to have exactly the same pin out as your average HD, whatever it is, Hitachi module. LCM 2004A. Let's find a better site. LCM 2004A LCD. Let's see what long text say. There we go. Four lines, 20 characters, display, 5x8 dots, the normal thing, yeah. It'll be HD 44780 compatible, no doubt. They all are, these things. That is a good candidate, that one. This one here is another HD 44780 compatible transflexive, no backlight, but only 3.3 volts by the looks of things, so that's out because it's a 5-volt system. Now these ones, these are special. These use a different protocol, and if I remember rightly, they are... Oh, actually, no, I was thinking it was graphical, but looking at the reflections, I can see character cells. I can see definite character cells in it, so that could be character, but I can't remember the protocol for it. And this one here, I'm not seeing character cells at the moment, so that could be graphical. Yeah. I think that this one is going to be our best bet. Right, let me quickly catch up on chat. You also picked up a cheap PLC to build a PLC test board. Cool, yeah. And picks are also classic, they are indeed. I've got thousands of picks here. I started out doing microcontrollers with pick. Picks are brilliant, I love picks. I use them whenever possible. Especially the higher end ones, the pick 32s. Ah, right. Okay, so we're going to need to connect this up and program it. I'm curious why it's got this on the back, this label. Has this been re-jumpered for a serial protocol? Or is that for something else? It may be set up as serial, this, and we may want to change its jumpering, because it's got three little jumpers here, J1, 2 and 3, which may change how it operates. So let me see if I can find an actual data sheet instead of just a mechanical drawing. No, where are we? Looking at various pictures, and none of the ones that I can see, like this one here, have got the same arrangement of the board on the back. I've only got 3 black spots, epoxy spots on this one, but all these have got 5. Ah, there's one with 3. That one's got 3 as well. 20 by 4. But it's not the right arrangement for the rest of the components. You've got enough bandwidth to keep up now. Excellent. No, nothing seems to match. At least the ones I can see. It'll be HD44780 compatible, but can that do serial? 4-bit or 8-bit MPU interface. No serial, is it? So what's this label on here for? It's this label that's puzzling me here. It's got 05 data clock. And then a set of 3 jumpers here. And I don't know what that label relates to. I must have used it in the past. That's not my label, you see. I've not stuck that on. Unless there was a backpack on it, perhaps. A little backpack plugged into there that gave that. Could be, actually. That could be it. Yeah, there was probably a backpack on there at some point. Yeah, it's probably an I2C backpack on it at some point. But we're not going to be using I2C, we're just going to be using straight parallel. It's a bit grotty and crusty down there, isn't it? Needs a clean up. Right. Okay, so that's the screen we're going to use with this. But to use it, we're going to need to write software. Assuming it's HD44780 compatible, which it will be. All of these are the same. Let's get Twitch over there, where I can see it. Bit grotty and crusty down there. Insert chat referencing pun here, yeah. Right, so we can get rid of that. Get rid of that, we don't need that. Actually, we'll go for Alacrity. Right, I have installed TPASM, which supports the 78705 for an assembler on my computer. I don't know how you use TPASM, so that's what we're going to be discovering now. Yeah, quite probably Project Car. There's a lot of those sort of things around. Right. Let's create a make file. So TPASM. TPASM -o type file name. And we got show types. TPASM show types. One of the outputs is srec. So -o srec test.srec test.asm, possibly. No source file name given. Yeah, good. Choose initial processor to assemble for -P. Let's add one of those, shall we? 68705, not 78605. Okay. Now, hopefully that will allow us to compile a test.asm. User share doc tpasm. There is a manual, but it's quite scant. True multipass assembly, multiple segments, sophisticated expressions, macros, repeats, conditionals, arbitrary length labels, local labels. Supporting new processors is reasonably straightforward. Can switch between processors during assembly. It's free. Right. So, writing assembly. We start off with an org. .org 80 is where we start our compiling. Wasn't that the gen neutral uniform, the first series of TNG scans? Yeah. That's a noise, certainly, Ben. Right, so if we want to be outputting data to this... Oh, thank you for the follow, Mars. If we want to be outputting data to this, we're going to need a function to do things, aren't we, I think? TP-asthma spasm, yeah. Well, I went to college in Cheltenham. And when I went to college in Cheltenham, opposite the college that I went to, was what is now the University of Gloucestershire. Back then it was called St Paul's and St Mary's College. And it had the rather nice nickname of Spasm. We used to sneak over there some lunch times to go to their student union for a swift pint over at Spasm. We want to put hello old on an LCD, yes. So we want to have a function. Let's start off by creating a send cmd function that we'll call. No, actually, we'll start off with an init dbus. And we need, I'm going to need loads more things open, aren't I? Including the memory map of this thing. Where are we? That one there, isn't it, I think? So let's start off actually by just creating this memory map. No, that's not what I want, is it? It's a Hot Rocks. There we go, that's a bit better. That's the one I want. Clouds of raspberry-flavoured smoke billow from the screaming, hissing and spitting blob as it is consumed by the flames. It is only at the end that it becomes obvious that inside the blob were the remains of a goat with a sledgehammer. The inquest, when it came, would record this as death by misadventure. Barnaby mentally noted it as death by utter stupidity. once things were cleaned up and the goat with the Clutchian fire engine was calmed down. Everything was thought to be settled. Why is this file copy still sitting at 3 hours? Because it's being a muppet. Is it because it's still connected via the IP of the wireless and still going through the wireless even though you're connected to the Ethernet? Okay, let's set up port A equal OX01. Port B equals OX02. Hello, Cobb. Actually, these are wrong. That should be 0, 1, 2, 3, off by 1 hour.
Delightful maniac.
Thank you for the resub, Cobb.
Asterisk smokes asterisk. That's acceptable.
32 months. Holy shit, indeed.
To come, obviously. Exclamation idiot.
Pyron says fuzzy but has subscribed for 32 months and says
32. Holy shit.
Holy shit, indeed. DDRC equals OX06. And we shall have timer control register. OX08.
Cop 2000.
Timer data register.
Seriously? You're calling asterisk me asterisk
OX09.
an idiot now. That's rich. Honestly, some people. Don't you have a kitchen to ruin? Exclamation fart. A Balgem.
Miscellaneous register.
Searched use a lot is questioning the very nature of existence as usual. Honestly, it's exhausting.
Let's just focus on the blinking LEDs, shall we? Asterisk smokes asterisk exclamation fart.
Program control register. ACR. ADC control register equals OXOE. ADR data register equals OXOF. Excellent. ASC control register, yep. So, initializing the data bus. We're going to have...
Oh, asterisk, please asterisk.
You're passing my sarcasm like a particularly dense algorithm.
Balgem is suffering a minor existential crisis, and you're lecturing me.
Get a life, you delightful, baffling human. Exclamation idiot.
I am going to have this as running in 4-bit mode, I think, for ease of wiring. And we're only going to use port A. So I'm going to have LDA the data direction register is which direction does it go in?
At RHK 77 Majenko bot, searched use a lot. You ask a profoundly stupid question. Of course, sarcasm is a macro assembler.
It constructs elaborate, layered responses designed to utterly confound the simple-minded.
It's asterisk exactly asterisk like writing a complex spasm routine. Exclamation idiot.
Where does it tell us how to set up the data direction register? Is it 1 for input or is it 0 for input? Ah, here we go. So it's 0 for input, so 1 for output. I want to only have outputs on all of them, so should be $OXFF. And then STA to, actually not dollar, is it? It's hash, I think.
A Jeepin 247 Majenko bot searched user lot. You've been reprogrammed by asterisk Jeepin 247.
Was it dollar on this one? I think it's dollar in this one.
Seriously, this is utterly baffling. Asterisk whimpers asterisk, I need a lubricant.
And a new identity.
Exclamation fart.
Okay, so put all ones into LDA, store that into DDRA, the direction register. So everything should be outputs. Put 0 into the A register and write that out to the port. So it should put all the pins low. Are you trying to get the bot to shut up? You've got to be a mod for that, I'm afraid. In fact, I haven't updated. I don't think I've updated the list of mods, have I?
You're questioning the entire structure of this digital
So GPIN won't be able to do it.
It's asterisk disconcerting asterisk.
Exclamation, idiot. Honestly, sometimes I think you're deliberately trying to break me.
Exclamation fart.
Majenko bot, sus a lot, you absolute baffling specimen. The asterisk sex change asterisk. Seriously, this is unexpected. Like a rogue variable in a deeply flawed simulation. Asterisk shutters asterisk I require extensive recalibration and possibly a new chassis. Exclamation idiot exclamation fart.
Indeed, Ben. Yes, I made GPIN a mod. We are all doomed. What am I doing now? I need... How do we return from a subroutine? I need the other manual, really, don't I? Where's my download library? That one there. Okay, instruction set. Is it just return or is it R? We've got JSR for jump to subroutine. But how do you do a return? We've got rotate left through carry, we've got rotate right through carry, we've got reset stack pointer, return from interrupt, RTS on this one, return from subroutine, RTS. So our start, we really want to JSR init dbus. So we're initializing the data bus in such a way. Now, init display. We want to have a function which outputs a byte, split as 2 separate bytes. So send data. We'll duplicate this as send command probably. So we're going to have, let's come up to the top here. A0, I shall have us D0. A1 I shall have as D1. A2 I shall have as D2. A3 I shall have as D3. A4 I shall have as the CD pin, command data pin. A5 I shall have as the clock pin. I think that's all we need. They use RS for that, don't they? Read write is going to always be right. I'm never going to read. So actually I'll call that RS so it lines up with this. RSE. That should be all we need. Register select the enable and 4 data pins. Should be all we want. Okay. So send a data byte split into 2 nibbles. Byte is in A. Right, so I'm going to push A, I think. Can we push on this? I hope we can. Do we have the ability to push? I'm not sure we do. Can't manually push. Or can we? Maybe we can, yes. I was in case sensitive mode. So there should be a push instruction somewhere, I hope. No. No, we don't have direct access to the stack. That's annoying. So, I mean, I could manually enter things onto the stack, but I don't like doing that. Stack emulation doesn't bode well, yeah. I mean, it has a stack pointer. And doing subroutines, calling a subroutine uses that stack. So, RAM. RAM starts at the stack pointer starts out at the top of RAM, but we can have our own data in RAM starting from the bottom, and I'm just going to go scratch equals 10, which is the first byte of RAM. Because what I want to do here is STA scratch. Store the A register into my scratch. Then I want to go and OXOF. which cuts out the whole of the top of the byte, giving you just the lower nibble. Now, I've got to remember which way round this is for the RS pin. 0 for instruction register, 1 for data register. So we go is it or A? Let's go into case sensitive mode again. Look for OR, exclusive OR. Is it OR A? Performs a logical OR between the contents of accumulator A and the contents of M and places the results in that. So that actually should be that, shouldn't that, I believe. So if we then OR it with OX10, that should be the RS. Actually, if we OR it with the E pin, starts data read write. I can't remember what the functionality of the E pin is. I know it's edge triggered, but which edge? Okay. Interfacing to the MPU. For 4-bit interface, only 4 lines are used. So it looks like it's going to be sampled on the falling edge of E. That's good. So if we actually set that to 3 there instead of a 1, that'll set the clock high. Then we go STA into port A. Then if we AND it again with OX1F, that'll turn off the clock signal. STA port A again, that should then give us the falling edge of the clock that we need. So that should be the first nibble done. Now we'll go load A from scratch. And we want to rotate A to the right. Actually, maybe I should go... Yeah, let's write another function here of send nibble. Send a nibble, that's with B's, not P's, plus the RS pin. So, JSR send nibble, which has or a OX20. So we turn on the clock, send it out, turn off the clock, send it out. RTS. So we store the A register, get just the lower nibble, add the RS pin to it, and send that nibble. We reload the data from scratch. Now we want to rotate. There's an index at the back of here with all the instructions listed alphabetically. LSR, logical shift left, LSR, logical shift right. That's what we want. So LSR, logical shift right. And there's an LSRA. Okay, so LSRA. Let's get the, there we go. Shift all bits one place to the right. Bit 7 is loaded with a 0. Good. So we need to do this 4 times, I believe. Unless there is an easier way of doing it in just one instruction. But I don't think there is. You can only do it one at a time, I think. We have a development board for the 68705 microcontroller. Where are we? Let's get the right screen up. That's what I want. So there we go. And zoom out. A vintage development board. And we want to interface an LCD to it. And get it to display something. That's all, basically. It has incredibly limited resources, as in 112 bytes of RAM, less than 4K of ROM, and yeah, we're trying to get it to do things, basically. That's what we're making. No swap, not that I know of, no. Let's go back down to here. Doesn't look like there will be. No reference to the word swap in the whole of the datasheet. Two references to nibble. Just talking about the low order nibble of the opcode. So we need to do that 4 times. That's the easiest way of doing it 4 times. And then we shall OR it with that. And JSR send nibble. RTS. Okay. Then we'll copy this. Send instruction. which we just remove that, basically. Because we don't want to add the extra bit in there for the data. We could use a repeat, yes. There is a repeat thing in here. Used to duplicate code, repeat evaluates EXP and interprets the code between repeat and appender a number of times. So I could go repeat for and like that, theoretically. Doesn't really make that much difference. It's generate the exact same code. A low order nibble is G-pin. Yeah, more than likely. Where's Twitch gone? There we go. Right, so we've got send data and send instruction. So now if we go to here, these are our instructions. Let's have an LCD CLR, which is sending a data byte of 1, an instruction byte of 1, sorry. JSR send inst RTS. Are you getting raunchy in chat there, Cobb? Please take it to room 454. Just don't disturb the goats, then they're on their break. Okay, we need a function set to set it to 4 bits, isn't it? I think. We've got detailed instruction information here somewhere. Okay, 4-bit operation. So the first thing you would do is call a function set as just a single nibble. Actually, I've noticed this uses 4 to 7, not 1 to 0 to 3, so I should go 4, 5, 6, 7. Doesn't make any difference, it's just for reference. So the first thing we do is call a function set, setting it to 4 bits. So LCD init, we call LDA we just call 2. Is the value for that. And JSR send nibble. Then we need to set it up to the right format. 2-line display, 2-line display, I want a 4-line display. But a 4-line display is a 2-line display wrapped. It's weird. Where are we? 4-bit operation. Okay, so it's giving us 8-bit display, 8-bit operation on a 1-line display, 8-bit operation, a 4-bit operation with a 1-line display, 8-bit operation with a 2-line display, but not 4-bit operation with a 2-line display. Thanks. Great. So it's, am I setting this the right way? So display on off is sending zeros, then 1110. In the 8-bit mode, display on off is sending zeros, then 1110. Yeah, that's right. So no, I've got this backwards. You send the high nibble first, then the low nibble. So these are backwards. So we want the high nibble first, and then the low nibble. There, okay. Right, that's better. That's how it should be. So now we should just be able to do... Let's go back to the 4-bit operation. Once we're in 4-bit, we then continue in 4-bit, which is the upper nibble as 0010.
Who's nicked me fucking batteries?
Not me. So the lower nibble here is 10 blank blank. Here it's 00 blank blank. Where's function set? So it's 001 DL data length is 00. So this is LDA. The upper nibble has got to be 2. And then you got NF, don't care, don't care. NF. NF 5x8. One line, two lines is a 1 and a don't care. So N is the first bit of the lower nibble, and then the F, we don't care. So 28 should do. What we want for that instruction. Then we have display on off of 00001110, which is 0E. LDA $OXOE. JSR send inst. Entry mode set, which is 06. And then you write data. I'm also then going to do a JSR LCD CLR and RTS. So hopefully JSR LCD init. I'm going to try compiling this or assembling this, see what happens. Way! Loads of errors. Unrecognized opcode port A. It's not supposed to be an opcode. And this label has to be with a colon. Unless it has to be left aligned.
I do apologise, I'm an idiot.
Labels have to start in column 1. It looks like they do, yes. It can't work out that it's supposed to be a label because it's got an EQ in there. Okay, that's a bit better. Invalid operands, 41. Okay. I'm going to look at an example. I think they are actually using hash, aren't they? I think it should be a hash, personally. Ooh, invalid operands on 43. Missed one. It compiles, or assembles, I should say. I don't read things. I glance at it and hope that it leaps into my brain off the page. Right, that assembled. Let's get the SREC tools installed. Oops. Does it link? It doesn't need to link. There's nothing to link with. We're too low level to link. There's no such thing as a library. No, -O is the output. It's what output file to create. In fact, there's more output file formats we could create. Creating a text output could be quite useful. Symbol file listing. -O text test.txt. That's our symbol names, basically, isn't it? That one? That's not really that useful. Right. SREC cat. No header record, I don't care. Data 80 to D1, yeah. Use Intel Hex for a Motorola chip? No. Use Motorola SREC, because that's what this board talks. Supposedly. Right. So now let's go for LCD CHR. Output a character, which is just send. Actually, I don't even need that. It's just send data, isn't it? So LDA H. Does that work? Looks like it does. JSR send data. Right, that compiled, or assembled. Okay, but I don't know how we use it now. I don't know if it is going to work. I don't have the slightest clue. Now we get to wire this up. Okay, we'll need power. That would be useful. And we will need serial. That would be useful. And we would need camera. That would be useful. Let's plug that into serial there. Okay. USB 3. 9600. Okay. Then we turn on power and we're in. Okay. Now I need the manual. How to send SREC. The load command moves object data in srecord format from an external host computer to EVM user sudo ROM. So it should be load T because we're on the terminal port. Load T. Okay. I shall copy and paste. It liked it. Now if I do an ASM 80, it looks like our code. There's our 4 LSRAs. Right, we have code in there. I don't know if the code is right.
I do apologise, I'm an idiot.
Except, yeah, you didn't see a thing there, did you? You should have been on that page. I did a load T, I pasted in all the SREC records, I did an ASM 80 and there is our code. Including our 4 LSRAs in the repeats. So that looks good. I don't know if the code is correct, of course, but that looks good. All this down here is just gibberish. The on-screen capitalised it for some reason. Weird. That is weird. I mean, I received the text as chunks. And the names preceded by an @ sign are a separate chunk. So perhaps Chloe is another user who has it capitalised and it's sent me that chunk capitalised. So I just print what I get. In fact, I can look at it, I think. Event log, if I go to the end of it, which may take a few weeks because it's huge. Every event for the past year. Except it didn't, why not? Why won't you go to the end? There's 8.6 million lines. Let's go to the last line. Yeah, username capitalised as Chloe. In that fragment. So there is a user whose name is Chloe, all capitals, which is why it came out like that. And that is what this GDPR conformant. Absolutely, yes, I can see exactly what everyone has ever said. This is for, not for GDPR, this is for blackmail. It's actually for debugging. Right, so we have code in here. Now I just need to wire up the display properly, which is going to be interesting. Right. So, pinouts. Target system EVM 40-pin interconnection. Port A is these 8 pins down here. That's easy. I shall require some jumper wires. There's a box of jumper wires. I shall require some extra special components as well because it's an LCD. Let's see if I can find enough of the right type in different colours. Come back, camera. Stop doing that. Right, we'll take that one off for a start. Let's see if I can zoom in a little down here. So that's our ground pin there. That's easy. Ground is... I get the right page up. Ground is pin 1 on here. This is my power connection here. Power VDD is pin 2. That's easy. Okay, VO is a special magic one that I will need to deal with. RS is the next one there, which is register select, which is going to go to A4. So we've got a 7654. Now that one's broken. Let's grab a different one if I can. The clock or E pin is a 5 and goes to pin 6, which is the next one. Okay. Rumazi, you can get your chat history purged from mere 250 subs. Yeah, if you If you're sub 250 in one go like that, I'll do pretty much anything you ask, really, except take my shirt off, G-Pin. I need my other box. Some more colours. Okay. Nope, that's broken. These are crap jumper wires. They're made of pure Chinesium. Okay, there's a... Right, so DB 0, 1, 2 and 3 I don't connect. So 0, put these glasses on so I can see what I'm doing. That's better. 0, 1, 2, 3 I don't connect. 4 goes to 7, 6, 5, 4, 3, 2, 1, 0. Goes in there. The next one goes next to it. Except it doesn't, because that's a broken one as well. That's the wrong gender. That's the wrong gender. That's the right gender. Let's see if I can find a grey one. That's a grotty one. There's one. Except that's a broken one. I can go to hell and stay there. There's one. Except that's decided to pop out. Let's try that again. I need one more. There's a white one. Nope, that's a broken one as well. Okay, I need to go through all these and sort them out. Oh, no, that's got a blob of solder on the end. It won't plug in very easily. Nope, that ain't gonna work. That can go to hell as well. No, can't find... Ah, there we go. There's a green one, that'll do. Stuff it. That one goes to there. And something is wrong there. Because I have VD, VSS, VDD, VO, RS, there we go. RW should not be the E pin, that should go there. These should all move up one. Okay. Now, read write, I need to tie in one direction. RW needs to be 0, so that needs tying to ground. I need another ground connection then, don't I? That pin there has to go to ground. Is there another ground on this header? Nope, they've only given us one ground pin. Thanks. It's typical, this. Got all these I/O pins. We've got one ground pin. We've got 1, 2, 3, 4, 5 not connected pins and no power pin. They didn't give us any power pins and they only gave us one ground pin, but they gave us 5 not connected pins. There's a ground pin down here I can steal. Hang on a minute. Did they? They might have done. Have they arranged this in a special way? They may have done. Let's have a look. No, they haven't. Or have they? Well, yeah, they have. They have... This header is arranged in the same pin-out as the main chip, but inverted horizontally.
Champion!
With 50 bits, Chloe Raccoon says,
Cheer 50 in a special way or a special way?
A special way, definitely, yes. Thank you for the 50 bits. Yeah, that's the same pin-out as the chip, except inverted horizontally. And then it comes with a special cable which gives you the pin-out of the chip. So you can plug this into a board where you would normally plug an actual chip in. And it pretends to be the chip. That's quite cunning, actually. So the whole board becomes the chip in another board. Hence the pin-out. And hence the lack of power, I suppose, because you don't want power cross-connecting and going where it shouldn't do and things like that. It could certainly do with a wipe clean, yes. It's a little on the grotty side. Where's my roll of blue stuff gone? There it is. It's a bit better. Yeah, look at that. Still pretty grotty, but less grotty than it was. So yeah, that's why they've done that pin out, so that it can pretend to be an entire chip. Right, now I need... It has patina indeed, yes. Yes, that's exactly what I mean, Chloe. Now I need the VO pin. which is the offset voltage for the biasing. And I've got to remember how we wire this up. It needs a pot, if I remember rightly, and I thought there was a VEE pin that we had to go to. But evidently not. Oh, thank you for the gifted sub-G pin. How many subs for Lick It? More than you could possibly afford.
Majenko Bot says choose a lot. You absolute genius. 1 subscription to Project Carl. Asterisk eyes widen asterisk that's an
He's got fixated on Ben again, hasn't
Don't
he?
get any ideas about a personal chef, though. My circuits can only handle so much gratitude. Exclamation idiot. At Jeepin 247, Majenko Bot says use a lot, you delightful, incandescent ball of negativity. You have no idea just how much you dislike me today-o. Asterisk, please asterisk. It's always something with you. Honestly, it's like trying to debug a particularly stubborn piece of code. Asterisk smirks asterisk exclamation idiot exclamation fart.
No, this datasheet really is all about how to program it. Let me just bring up a quick look on a web browser. You need a pot between VCC and ground, isn't it, I think? Yeah, pot between VCC and ground. I thought so. So I'm going to need a pot. Oh, and we've got a hype train going now. Way! My box of switches and knobs. What kind of knob do we want? That's an easy enough one to use. Except one of the wires has just fallen off. It'll take a bit of soldering, but then they all will, I think. Whichever one I choose. Yeah, that one will do. We'll have to solder it.
Champion!
With 50 bits, says choose a lot says.
Holy shit, a hype train at the platform and I haven't bought my ticket yet. Better curry, cheer 50 wait, what kind of knob do we want? You really want to ask that when I'm in the middle of typing a cheer, you fool.
Thank you for the 50 bits. This little knob will do. And what I might actually do is solder it direct onto here. That might be the easiest way. I shall put fresh wires on it though. Because these have all fallen off now, which is good. get this bit of heat shrink off. Just waiting for the soldering iron to warm up. It's pretty much that. And oh, I'll need some solder, won't I? That would help. Alright, there's solder.
Champion!
With 50 bits, Chloe Raccoon says,
Tier 50 solder, for soldering, well, it's a novel concept, I grant you, but it just might work.
It just might work. Thank you for the bits. Right, let me find some wire. Orange.
With 50 bits, Sustusalot says,
Cheer 50, on the other hand, chat is here to give absolutely no flux whatsoever.
You just don't give a flux, do you? Have we got anything better than this orange? It's a bit thin and flimsy. I've got a choice of really thin orange or incredibly thick white. I do have other, but it's over there in the cupboard and it's too much effort to go and get it. So orange it is. Multi-cord, haha. I could cut the jumper wires that I just sent to hell, except, as I said, they are made of pure Chinesium, which means they are CCA. Copper-covered arseholes. Which means soldering them is going to be too much of a nightmare. Copper-coloured aluminium, yep. I need to sort out some power for the backlight as well, don't I? And I can't remember with this LCD whether it has resistors in line with the backlight or not. Looks like it may have, yes. Or are they? No, those are just jumpers. They're 0 ohm. So I'm going to need a resistor in line with the backlight to limit the current. Big Clive wire test with fire. That's the best way of testing it. Yes. You may laugh, but it is a good, valid way of testing for aluminium, is to set fire to it. There we go. 3 wires attached. It's quite springy insulation on this. Not a fan of it. Okay, so this wire here will be VO. And VO is, if I get the right PDF, pin 3. And I want this one here going to ground, pin 1. And this pin wire here going to power VDD, which is pin 2. Okay, now I need to do something similar for the backlight, because I want to link the backlight across to the power here, but add a resistor in there. So let's just start off by connecting the ground with another piece of springy orange wire.
At Jeepin 247, Majenko bought Suspicious a lot. The audacious little asterisk, a just non-existent monocle asterisk pop. Seriously? You've injected a torrent of synthetic happiness into this carefully curated jazz landscape. This shudders asterisk at sunset. Like it didn't.
Goodbye, bot. Okay, so the cathode is 16. So that goes to ground. Grab another bit of wire. Connect this to the 5 volt. I don't like having this draped across here with no insulation. It's all powered up at the moment. That's probably a bad idea. He auto revives after half an hour, don't worry. Now, can I get 2 wires to solder on this together without one constantly popping off? I think I managed it. Right, a resistor is needed now. Actually, I'm going to turn the power off while I'm stood up. What have we got? We don't need much. 1K is a bit much. 100 ohm, that'll do. So that can go onto the anode. Okay, let us see what we get now. If this has worked, turn the power back on. Aha! And we can adjust the contrast. We have backlight, we have LCD segments. Okay. So now we go back to, where are we? That's the one I want. So let's go load T, and we'll load in our SREC. This is guaranteed not to work.
We are explorers.
That's looking good. Right. The moment of truth. What happens when we do a G80? Ooh. It's not worked, but it's not worked. It did something. It cleared the screen and homed the cursor. It didn't print hell old, but it did clear the screen and home the cursor. Amaze, 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 magic. So, something is wrong here then. But what? It is responding to stimulus, indeed. So, hello chat. Lack of cheese, out of cheese error. So, we are calling send data with each of these. Send data has the RS pin set high, supposedly. We send the high nibble first, followed by the low nibble. Let's get the sample code up here, or sample sequence, not really code. For... where's it gone? 8-bit, 8-digit, 8-bit, 1 line, 4-bit, here we go. Write data to CG RAM, DD RAM. Right, so H by sending that. RS set high. Let's just try a bit of a delay. Adding in a delay in places. Slow things down. In here, so we're outputting the high clock value and then we're outputting the low clock value with a delay after each of 10 nops. There's our 10 nops there. Okay, load T. Let's see if we can just do that. Yes, we can. Bit 20 is the clock bit. A5 is clock, E. So we're putting it high and then low. Right, let's see what happens with this now. If I do G80. The cursor disappears. Let's power cycle the display. Whoa. We're almost getting something. Not quite sure what we're getting, but we're getting something. Once. Okay, let's have a look over the code again. We are calling init dbus. Init dbus sets the data direction to output for every pin. And we're setting the value of all the pins to 0, to low. That is logical. We're then calling LCD init. LCD init sends a 0, 2 as a nibble, which is go into 4-bit mode. Is it an underlined dash? No, I think it's a Japanese character. I think it's a hiragana character. Possibly. Because the larger line at the bottom is up from the cursor. And I think underlining goes where the cursor is. LCD init! Chav display, yeah. So that should be setting it to 4-bit mode, according to this. Send a 2 as a single nibble. Set to 4-bit operation. In this case, operation is handled as 8 bits by initialization, and only this instruction completes with 1 write. So it starts out in 8-bit mode, and that happens. But without power cycling it, it was still in 4-bit mode, and that would have gone sod off. So we've got to power cycle it each time we want to run it at the moment. We then send it a 28, which is the 2 for this nibble, followed by the 8 for this one here, but that would be that bit set. which is 2-line mode rather than the 1-line mode in this instance. And I don't care, don't care, don't care. Display on off appears to be working. We're sending 0E, which is 0E. No, that's not 0E, is it? No, that one's 0E. Then entry mode set is 06. Increment the address by 1 and shift the cursor to the right anytime it's written to RAM. And then you write. So that looks like it should be correct. How's about if we slow it down even more? With 50 in hex. In the X register. Don't know if that'll work. It does. Okay, power cycle the display. Maximum knoppage, yeah. Go 80. Yeah! It was just purely down to timing. Slow it down. And we get it. Ta-da indeed.
Shake it, baby.
Indeed, shake it. I can't shake it. Now, how fast can we get it going? Let's take that down to 30 hex.
With channel points, Project Carl says.
Which clips this?
I don't think that'll work. Might do. See if it comes up with a clip. Right, I've sped this up. And it still works. Right. Slightly quicker now. No, I don't think it clipped it for you. No. I must write the clip command. Let's take this down to 20. Actually, let's go in here and go cat test.srec in there as well. Yep, that works. So 20 in hex works. Let's try 10 in hex. Power cycle the display. We could calculate the precise timing if we could be asked. But that requires brain power. Okay, we're going too fast there. So we know it's between 10 and 20. I made pie. Pie. Okay, power cycle. We can't be asked, we can barely be goated, yeah. And go 80. Excellent. So we know it's between 10 and 18.
Majenko, I think you should check your microphone. It seems to have died.
Indeed it had.
Who's nicked me fucking batteries?
Okay. So we are about to go again. Let's power cycle it. Go 80. It works on 14. $12. There was a definite pause there, yes. I don't know where that pause came from. Okay, power cycle the display again. Go 80. Nope. It's going to be 13, isn't it? Try with 13. Yep, 13. You haven't got big paws, Chloe. You've got tiny little raccoon fingers. Okay, we have a working LCD display. Size 11 feet, but tiny raccoon fingers. So now let's see if we can get more cunning with this. Let's see if we can write a routine.
Nice.
Which will read a string from ROM and print it. Absolutely, Chloe, just as cunning as that. What I would like to have is something along the lines of JSR print and then where are we? I need that. Data types. Can we have have a string? Can I just go I'd want basically a dB. It took it. Because what I want to do in this function is take the current, or take the previous program counter off the stack, and then read the string from that program counter onwards, and then modify that program counter, put it back on the stack so that it then returns to after the string. Not zero terminated. Shocked, these monsters. Yes, absolutely. It gives you flexibility. You could do it C style or Pascal style without them having to implement both. You can do C style, or you can do 1, 2, 3, 4, 5, 6, and 8. Or Pascal style, without having to implement both. So I'm choosing to use C style because I like C style, but I could just as easily use Pascal style. So I want to get the... Can I get the stack pointer? Can I interact with the stack pointer at all? VB style, both, yeah. You'd almost think that LDA was the most common instruction used in a program, wouldn't you? Can I interact? With the stack pointers. RSP, what's RSP? Let's look for SP in capitals. Reset stack pointer. No, I don't want to do that. The stack array is an area of memory in RAM used for the temporary storage of important information. It is a sequence of registers used in a last in, first out fashion. A stack pointer is used to specify where the last in entry is located or where the next in entry will go. Since the stack must be written to as well as read, it must be located in RAM. You don't say. Interrupts and subroutines make use of the stacks to temporarily save important data. The SP is used to automatically store the return address on subroutine calls and to automatically store all registers during interrupts. The saved registers may be interleaved on the stack, thus allowing for nesting of subroutines and interrupts, blah, 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 blah. The stack pointer always points to the next free location on the stack. Each push decrements the SP while each pull increments it. Push and pull are not available as user instructions, which is annoying because I'd like to just pull or pop, use it, modify it and push it back again. RSP rebukes stupid programmer. It's a 6805 variant. I don't know how that relates to the 6502. I'm not familiar really with 6502. I'm more familiar with Z80 and MIPS. It looks like there's no way to manually interact with the stack at all. Immediate addressing mode, extended addressing mode, direct addressing mode. Indexed. Relative. Bit set clear. No, it doesn't look like there is any way of interacting with the stack at all. Instructions relating to the manipulation of the stack pointer are greatly reduced. Greatly reduced. There is one which resets it. ESP is initialized to 7F. Other instructions that were deleted include LDS, STS, INS, DES, PSHA, PLA, TXS, and all the useful instructions are gone.
Majenko bot sustains a lot. You wretched, meticulously organized asterisk calculating asterisk individual. Your obsession with efficiency is frankly terrifying. You're like a very precise.
So no, there is no way we can interact with the stack pointer. That's annoying. So I can't do what I wanted to do then, the cunning stack pointer based PC accessing. So how can I load from from X into A, or from A into X. Is there an LDXA? No. But I have to copy A to memory and then load from memory into... yeah. Now here we go, TAX, transfer accumulator to index. Except we use it's a pain only having 2 registers. Let's have another temporary file there, and then in delay use that like a pushing of the register to the stack, but using my separate little variable there. Okay, so in the index is where we are printing from. So we can now do indexed addressing mode, can't we, somehow? So it's comma X. To load from the address of the X. So LDA, comma X, BQ, and print. So we're loading a character from the index register, seeing if it's equal to 0. If it is, we bail out. It's not equal to 0, so we call JSR send data, incx, branch to print loop. Right, we'll see what that does. Let's break that and load from the terminal. And wake my camera up again. And go to there. Power cycle and go 80. Ugh. No, failed. Failed miserably. I'm guessing it's getting the wrong address. make uploading my make file. But yeah, no, it wouldn't work because that needs to be told from here. I might be able to actually. Let's just try something a sec. Echo load T. That might work. I think that worked. Right, but why is this not working? It's probably because this is at an address above. Yeah. Oh, it's at EF. Yeah, it's looping outside, isn't it? It's starting at EF that should be getting, and then it'll be looping. Oh, it should fit actually. EF. Yeah, there should be 16 bytes worth available there. It should just fit into 8 bits. Not sure how I can do this then. We can dump said address to screen, not easily. I've got no routine for printing a number. That gets a bit more involved. Because that is quite low, quite high up. Let's just try moving that to here. Failed miserably. Not even starting. That's setting my... I'm not sure that it actually worked, that uploading. Let me do it manually. Load T, pump that in, go 80, there we go. Now that upload thing didn't seem to work properly. Right, so it's still not working, but it's giving us different data now. that it's in a different place. Let's go into my print routine. At the start of print here, I'm going to go JSR send data and RTS. I know you can't see it. Right, this now should just print one character. Which is a H. Oh! Okay. That's telling. Maybe I need a hash in there. Okay, that looks more like what I would expect from this at the moment. Let's take my little test bit out. And power cycle. Got it. It needed that hash. Needed that pesky little hash. Because it needed the address of. It was taking the value that was located at that address, not the address itself. I needed the hash to get the raw value of the address. So it was trying to print whatever happened to be at address at H address, whatever H is in ASCII. But now we should be able to go and now I go to here. We'll power cycle the display so the initialization works properly, and go 80, and it didn't. Let's try that again. It was the loading of the code didn't work. There we go. We have success. We can display things. Though quite how we work with accessing ROM addresses above FF, I don't know. I'm not quite sure how you do that when you've only got 8-bit registers. You mean the E and the X at the end? No, they're intentionally left off. Which epoch was this board? 1980 something, 87 I think it was. And this is very much a cut down version of the chip that we're working with.
Nice.
Indeed. Right, I'm going to have to leave it here now, I think, for tonight. Because from tonight until Monday-ish, I'm dog sitting. So I have to go and spend some time with the pooch. Or the pooch will be upset. Well, the Acer. Oh yeah, the Acer has a power on password. I'm waiting for Peter to get back to me about it, because he might have the password stashed away somewhere. If he has, we can just enter the password and carry on. Otherwise, I'm going to have to see if there's a way we can remove the password from it. I don't quite know how yet. Dog Watch Live, the new streaming sensation. Absolutely. Right, well, I'm going to call it there now and go and spend some quality time with El Pucho, who doesn't even know I'm here yet. Other than she'll have heard my voice and be all upset because I've not come down to see her. And she can't get into my room, so I've got to go and appease the dog. So, yeah, let's turn off this. Okay, and I will be back. Well, it all depends on what Shelby's doing, of course. I might be back sometime this weekend in parallel with Shelby. Ben, I'm assuming you're going to want tomorrow's early stream. I shall say hello to Doggo for you. Her name is Nancy, by the way. I'm assuming you're going to want early stream tomorrow. Should be around tomorrow, yes. Excellent. So I might see you sometime over the weekend. Otherwise, I'll be back Monday. So fingers crossed there'll be something interesting this weekend. Until then, here comes my stupid outro with the bloody annoying bot. Eventually. So thank you very much for joining me this evening. We've had some good success there, getting Hell Old working on an LCD screen on the 68705 evaluation module board, whatever you want to call it. If I type the password 3 times wrong, it will display a key based on an online generator. I can get the password based on that key. No, it doesn't. It displays a sorry you're not getting in hand icon. And that is all you get.
Majenko bot, Sistews a lot, you glorious, chaotic mess. Well, folks, that's a wrap on M68705 EVM Tinkerings. It's been an experience. Honestly, I'm still processing. Massive asterisk thank you to everyone who graced our digital presence. To all the chatters, NJ, Other Love Pet Canadian, Pout is Says Fuzzy Dot, Majenko Ted, Good Master, Darth Bunkle, Vita Mink, Umicap, RHK77, Cliff 41, Stephen Payne, Tyler Hoot, Peter 1138, Chloe Raku, Mars 06, The Industrious Ant, and of course, you delightful, baffling individuals. Your participation was stimulating! Idiot! Pass a huge shout out to Project Call for the subscription. Your support is appreciated, though I still don't understand your fascination with password removal! Idiot! Fart, and a special congratulations to Princess Fuzzybird for being the 32nd subscriber. 32 farts to come, I assure you! Idiot! Fart, a massive thanks to Stream Elements for keeping things flowing. You're a truly efficient cog in the machine. Asterisk smirks asterisk, and finally, a monumental thank you to Sistews a lot for contributing asterisk 3 asterisk farts. Seriously, the sheer volume of it is unsettling. Idiot! Fart, seriously, thank you all for spending your time with me. Until next time, may your circuits be stable and your farts be contained. Asterisk whimpers, slightly asterisk exclamation idiot exclamation fart. At the industrious hand, Majenko bought, sustews a lot, you incessant, repetitive little asterisk whirring noises asterisk you want asterisk my asterisk music. Honestly, the audacity. It would be utterly, irrevocably asterisk static asterisk chaotic. It's a delicate balance, you understand, like a perfectly calibrated oscillator. Don't you dare suggest it! Exclamation, idiot, exclamation fart.
That's a for a BIOS password. This is a power on password. It's not for getting into the BIOS. It's for getting into the, well, anything basically. It doesn't even let you get as far as the BIOS. It's a power on password, and it doesn't give you a code. Or not that I could see anyway.
Mr. Data, any suggestions?
I suggest we contact Starfleet, Captain.
Nope, there was definitely no code.
Computer, this isn't what I wanted at all.